Welcome back to Mindcast. I'm your host, Will, and today I'm absolutely buzzing to share what I witnessed at one of the most exciting AI conferences of the year. The Ultralytics Yolo Vision 2025 conference, or YV25 as the cool kids are calling it, just wrapped up in London. And let me tell you, this wasn't your typical tech gathering. This was a glimpse into the future of computer vision and AI. Picture this: the Pelican in London, packed with some of the brightest minds in AI, all united around Ultralytics' simple but powerful mission statement. And I quote, "AI should be open, accessible, and powerful enough to change the world." Now that's a mission I can get behind. But here's the kicker. They didn't just talk the talk. They announced some absolutely game-changing news that's going to shake up the entire computer vision landscape.
Now, before we dive deeper into the technical announcements, let me paint a picture of just how significant this moment is for the AI industry. You see, when Ultralytics first introduced YOLO, you only look once, back in the day, it revolutionized object detection by making it faster and more efficient than anything we'd seen before. But what we witnessed at YOLO V25 wasn't just another incremental update. This was Ultralytics positioning itself as the definitive platform for computer vision. And frankly, they're making a compelling case.
The biggest bombshell? Ultralytics just secured $30 million in investment from Elephant and Square One. But wait, there's more. They're completely rebranding their models to YOLO 26. Now, if you're thinking, wait, what happened to YOLO 11? You're not alone. Glenn Jocher, the CEO, explained they're taking a page from Apple's playbook, simplifying their version numbers because, frankly, YOLO 11 wasn't just an incremental update from YOLO 8. It was a complete architectural revolution. Smart move, if you ask me. Let me put this $30 million investment into perspective for you. In the world of AI startups, especially in computer vision, securing this level of funding isn't just about the money. It's validation from serious players that your technology has real commercial potential. Elephant and Square One aren't throwing money at moonshots. They're investing in proven platforms with massive user bases. Ultralytics claims over 10 million downloads and deployments across industries ranging from autonomous vehicles to medical imaging to retail analytics. This investment signals that computer vision is moving from experimental tech to mission-critical infrastructure. But let's dive into the technical meat and potatoes, because this is where things get really exciting. Glenn revealed they've achieved a 43% improvement in inference speed. 43%, that's not just an incremental gain, that's a massive leap forward. And here's what really gets me excited. They've cracked the code on small object detection. You know how traditional YOLO models would sometimes miss those tiny details? Well, those days are over. The new architecture can spot objects that previous versions would have completely ignored.
Now, when I say 43% improvement in inference speed, let me break down what that actually means in the real world. Imagine you're running a security system analyzing video feeds. With the previous models, if you could process, say, 24 frames per second, you're now looking at over 34 frames per second with the same hardware. That's the difference between missing a critical event and catching it in real time. For autonomous vehicles, this could mean the difference between detecting a pedestrian stepping into the street versus a potentially catastrophic miss. And for manufacturing quality control, it means inspecting more products per minute without sacrificing accuracy. This isn't just a number on a benchmark, it's a game changer for real-world applications.
Now let's talk hardware, because this conference was basically a showcase of who's who in the AI silicon world. First up, Intel. And honestly, they surprised me. Remember OpenVino, that neural network format that Microsoft dropped years ago? Well, Intel's brought it back with a vengeance. They demonstrated a 12 times improvement in inference speed by converting PyTorch models to their hardware architecture. 12 times! And here's the clever part. Their optimization tools leverage every single processing unit available. CPUs, GPUs, and NPUs working in perfect harmony.
Intel's resurgence in AI inference is particularly fascinating from an industry perspective. For years, NVIDIA has dominated the AI hardware conversation, especially in training large models. But Intel is making a strategic play for the inference market, where models actually get deployed and do useful work. Their approach is clever. Instead of trying to out-GPU NVIDIA, they're leveraging their massive install base of CPUs and their expertise in heterogeneous computing. When they show a 12 times improvement, they're not just optimizing for their latest silicon, they're making existing hardware more capable. This could be huge for enterprises that don't want to rip and replace their entire infrastructure just to deploy AI models. It's David versus Goliath, but David has some pretty smart stones. But NVIDIA wasn't about to be outdone. Angus Sidbury took the stage to introduce Thor, their latest Jetson chip, and the numbers are absolutely mind-blowing. Compared to the Orin AGX, Thor delivers 7.5 times the inference ability, 3.5 times better energy efficiency, 3 times the CPU performance, and 10 times the I/O throughput. Oh, and it supports FP4 precision for faster, smaller models without sacrificing accuracy. The dev kit will cost $3,500, which, honestly, isn't bad considering what you're getting. The implications of NVIDIA's Thor chip extend far beyond just better benchmark numbers. That 7.5 times improvement in inference ability means we're looking at edge devices that can run models that previously required cloud computing. Think about it. Autonomous robots that don't need constant internet connectivity to make critical decisions. Smart cameras that can perform complex scene analysis without sending data to the cloud, or medical devices that can provide instant AI-powered diagnostics at the point of care. The $3,500 price point also signals NVIDIA's commitment to making this technology accessible beyond just the largest tech companies. When you compare it to their high-end data center GPUs that cost tens of thousands of dollars, this is practically democratizing access to cutting-edge AI hardware. Here's where things get really interesting for makers and robotics enthusiasts. D-Robotics showcased their RDK X5, which has the same form factor as a Raspberry Pi 5, but packs an MPU with 10 TOPS performance at just 8 watts. Michael Hart from Mike Likes Robots demonstrated it running YOLO 11 at 30 frames per second. Plus, it comes with pre-converted models ready to use and seamless ROS 2 integration. This is exactly the kind of accessible edge AI we need more of. One of the most fascinating discussions was the panel with Sony's Yuki Tsuji, Raspberry Pi's David Plowman, and Glenn Joker. They revealed the story behind the Raspberry Pi AI camera with Sony's IMX500 chipset. What's brilliant about this collaboration is that it offloads neural network processing directly to the sensor itself. Yuki explained that Sony sees classification as the natural evolution of vision sensors, moving from simple image capture to actually understanding and categorizing what they're seeing. It's like giving your camera a brain. This collaboration between Sony and Raspberry Pi represents a fundamental shift in how we think about AI processing. Instead of capturing images and then sending them elsewhere for analysis, we're moving computation right to the point of data collection. This isn't just about speed, though eliminating the need to transfer large amounts of image data certainly helps with latency. It's about privacy, security, and efficiency. When your camera can classify objects at the sensor level, sensitive data never needs to leave the device. For applications in healthcare, security, or personal devices, this is transformative. Plus, Sony's expertise in image sensors, combined with Raspberry Pi's commitment to accessibility and education, means we're likely to see this technology in everything from hobbyist projects to commercial surveillance systems. It's democratizing AI in a way that would have seemed impossible just a few years ago. But perhaps the most eye-opening presentation came from HuggingFace's Merv Nguyen on multi-modal AI. She introduced us to vision language models that can not only understand scenes,
but actually tell you where objects are located within them. Models like Small VLM, QN3 LemiVL, and Florence 2 are game changers. These aren't just doing OCR, they're actually parsing documents with diagrams, tables, and figures, understanding the relationships between different elements. And here's the kicker, Small VLM2 can run locally on your device. Now let's talk about the NVIDIA challenges, because competition is heating up. DeepX rolled out with some bold claims, a 20 times improvement over NVIDIA Jetsons with their DX-M1 board, 25 TOPS performance, 5nm process, consuming less than 5 watts, and supposedly 90% cost savings. That's a lot of nines in impressive numbers. Their boards are manufactured by Samsung, and they're already available through DigiKey, though good luck finding them in stock right now. Axelera AI brought their own silicon to the party with the Metis IPU, one of the first digital in-memory compute chips to hit the market. They live demonstrated YOLO 26 before its official launch, processing 16 video streams in real time. 214 TOPS performance in a module that runs between 4 and 7 watts. Their SDK is already available on GitHub, and you can buy their modules directly for around £190. The competition is real, and NVIDIA should be taking notes. AMD wasn't about to be left out of the conversation. Cheng Lui introduced their M1355X with a 35 times performance increase and support for FP4 precision, just like NVIDIA's latest architecture. Their ROC M7 software stack delivers 3.5 times faster inference and 3 times faster training compared to previous versions. They've even launched a cloud facility to encourage developers to try their stack. Open by design, trusted at scale, empowering developers. That's AMD's rallying cry, and it's compelling. But perhaps the most thought-provoking moment came from futurist Gerd Leonhard. While everyone else was talking about technical capabilities and performance metrics, Gerd forced us to step back and consider the bigger picture. He posed some uncomfortable questions about responsible AI development and whether we should leave the future of artificial general intelligence in the hands of a few powerful entrepreneurs. It's a sobering reminder that with great technological power comes great responsibility. So, what does all this mean for the future of AI and computer vision? We're looking at a landscape where edge AI is becoming incredibly accessible and powerful. The barriers to entry are crashing down. Whether you're a maker with a Raspberry Pi, a startup with a limited budget, or an enterprise looking to deploy at scale, there are solutions emerging for every use case and price point. The democratization of AI isn't just a buzzword anymore. It's happening right before our eyes. The competition between hardware vendors is fierce, and that's fantastic news for all of us. When Intel, NVIDIA, AMD, DeepX, and Axelera are all fighting for market share, innovation accelerates and prices come down. We're seeing performance improvements that would have seemed impossible just a few years ago, all while power consumption drops and accessibility increases. As I reflect on everything I witnessed at YOLO Vision 25, what strikes me most is how we're at an inflection point in AI development. The technical barriers that have limited AI deployment for years are crumbling. We now have models that can run locally on devices, hardware that can process multiple video streams in real time while consuming less power than a light bulb, and software stacks that let developers deploy sophisticated AI without needing a PhD in machine learning. But with this accessibility comes new challenges. How do we ensure quality control when anyone can deploy AI systems? How do we maintain privacy and security when AI processing happens everywhere from your phone to your doorbell camera? And how do we foster innovation while preventing the kind of surveillance dystopia that science fiction has warned us about? These aren't just technical questions. They're questions about the kind of future we want to build together. That's a wrap on today's Mindcast episode covering the incredible Ultralytics Yolo Vision 2025 conference. From Ultralytics' $30 million investment in YOLO 26 rebrand, to the fierce competition in AI silicon, to the philosophical questions about our AI future, this conference had it all. The future of computer vision is bright, accessible, and happening faster than most of us imagined. Until next time, keep your minds open and your curiosity flowing. This is Well, signing off.